MCPs that actually works in production. So that's the topic for today, how a pro ships MCPs. So hi everyone, this is Vishesh again. So this is from experiences of building, and this is almost after 1 year from the when Anthropic announced their MCPs on the cloud models, and this is almost building like 40 to 50 plus projects on MCPs in production level projects on MCPs, delivering and shipping into projects. The kind of learning it all together. What breaks, what's overlooked, how Pro ships MCPs. So MCP is the model context protocol. So the biggest problem is it worked in demo, it failed in production. What's the biggest thing that's happening with the teams tested one happy path, one huge tool catalog, one log finder, discover too late, permission, latency, rate limit, schema upgrades, audit, all needs, right? So first of all, you need to understand that MCPs are not just a magic wand that you throw all the tools at. So MCPs, people understand that you throw a bunch of API tools to them, bunch of API endpoints to them and documentation to them, throw it them, they'll magically understand how to call the tools, how to do that. Ideally that's what it does, but it doesn't happen that way, right? That's only 20%. Accessing the tools, it's all 20%. That's true for all the developers also, right? Even if you just give the access to all the developers tools access, that's not development, that's not engineering. Engineering isn't decision making, it's governance, right? This is what the layers MCP also work functions at. Tool access is just 20% of the overall build. The 80% is when to call, how to call, when the call fails, what is the fallback strategy, what are the governance strategies. All of these together creates a good MCPs that is in production. And even if the underlying layer changes, how does the upstream downstream reacts, all of these propagation is what goes into production, right? And how to actually build, this is what we're going to see today. So what people think MCP is versus reality. Misconception: MCP is a wrapper for function tool calls. Absolutely not. Expose every API endpoint as tool. If the model I can call tools, we are done. Failures are model issues. Reality: MCP is a standard client server contract for tools. So the hard part is decision, when, what to call. You must validate, observe, and recover from failures. Governance matter, auth, audit, version rollouts. Absolutely. So, the biggest myth is that MCP is not just the wrapper function calls. Uh, MCPs are, there are client to server interaction. There are decision making endpoints. There are fallbacks that's all going to happen. There is a database. It's a whole software in itself. It's not just a layer in software, right? This is just, the biggest myth that people understand. It is a consumption layer. It's not a consumption layer. It's a whole segment of a software itself. And the best way to understand MCP is to understand it as a completely different, separate software altogether that has its own governance mechanism, that has its own decision auth layer, that has its hard auth part, when to call, what to call, client server interaction, tool resourcing, planning, and all of that stuff here. So this is in production level architecture of one of our tools that we built here at goML, where we built it for an healthcare customer, where it's an MCP market. It's like a motherboard solution where multiple different layers of different tool callings, different softwares comes together, interact at a singular platform, and how from that multiple tool calls are happening, multiple responses are getting generated, and how it is traversing there. This is the complete runtime engine. I'll come to this architecture once again before going through and understanding what exactly MCPs are. So how to build? Let's take the problem statement again. That today, let's assume that the problem statement that we had, that we want to build an MCP for a healthcare, which is integrated with your lab reports. It is integrated with your diet and nutrition. It is included ordering food. Everything that is included in healthcare. So we'll come to that. So let's start from the basics, right? Let's assume now again we have to build an MCP that is integrated with 20 plus different services, different third-party services coming to a kind of a system, which system has to make a call based on let's assume it's like a chatbot where user is interacting with the chatbot, and based on that, to get certain information, to do certain actions, to do variety of different stuff, get actions, get information, do all this tool callings. MCP has to that there needs to be that action needs to perform. So how would I do it? How today, if we want to, let's approach this via extremely basics. If today we have to build that system, or today perhaps again, let's go to the basic. Let's understand this as a software problem. I would think about planning. The planning MCP is right, understanding what we have. So basic starts from that, okay, these are the 10 different tools that I have in my corpus. These are their endpoints. This is the endpoint descriptions. Okay, that's first thing, is listing that whatever we have. Now what I will think about is that, and what kind of teams fail today to do is they throw this to kind of LLMs, right, and leave it to LLMs to understand that the right way is to do coverage. Coverage is creating scenarios, creating your all possible diversified scenarios where, stage where, okay, kind of where there are level 7 of calls, right? When user types this, I'll go to that. I'll extract this parameter from the user query. Based on this parameter, I'll call the API number 1. From that API number 1, I'll call API number 2. API number 2 data, I'll call API number 3. API 4, take this action, wait for this response, then I'll call API number 5. This is scenario number 1. Such scenario 2, scenario 3, I'll do that. Once I have this coverage of scenarios, it gives us two things. One, it gives a prompt, a good level of chain of thoughts, that whenever a new scenario comes, how should I approach it? And not necessarily that, LLMs are smart enough that even if you give 80% of the coverage, or even 60% of the coverage, they would be able to cover the rest of it. So best part is that cover the diversified scenarios into your contact server, and it doesn't need to be as deep. It can be high level one liner as well. Scenario 1, when it happens, do this. When it happens, do that. So that's part 1 of the problem. Part 2 of the problem is giving LLMs again the liberty to fail. This is again in context of, when this kind of parameter happens, this is the schema that you need to follow. And when this kind of schema does not happen, there might be 3 reasons for it, right? What are those 3 reasons? The 3 reasons might be that either you have done a wrong parameter extraction. Second, either the API is actually failing. There is actually certain level in a downstream. Either third, there is a contextual error. The data that you're trying to extract might have surpassed the context limit of whatever we have, right? So for that, we would keep some sort of quality gates at every stage, right? For context, we'll keep that, whatever information comes out of that passes through context. It will truncate the responses, or we'll perhaps paginate the response based on the scenarios. That is something that we need to do at it. When it comes to the API fallback, then we need to have a very static error message that, whenever this kind of things happen, do a try and accept loop or something sort of that. Maybe, you create a wrapper around all this API endpoints, like a function call, and let LLM calls that function call that gives this try and accept. There is a very static error message, this API is failing. So, it can understand that it's an actual API problem. First is a wrong parameter extraction. If it is a wrong parameter extraction, it should always go through another agent that is a model reflection, which says that, whether, this is what the parameter I've extracted, this is the API that I'm going to call. Am I meeting the schema requirement? That structured output should go to a validator. The validator should say, yes, you're meeting all the criteria, you're good to go to call. This is a really needed loop. So every API call that happens in MCP should be go through a maker checker process. Every tool should be followed with a maker checker process. So maker is, parameter extractor, basically parameter extractor plus tool calling. Checker is considering it has extracted the right parameter, it is calling the right tool. This two maker checker process should be there almost in every tool calls that we are doing over here. And most important part when we're talking about MCPs in production is maintaining the logs, the trail, the audits. MCPs needs to log whenever they're calling something, so that it's not only about related to session, but also what I've already called, what information I've already. That context is really important for further agents to understand the MCP. Try to understand something from a real life example, right? So as we mentioned, that tool calls are only 80%, decision and recovery are 80. Tool calls are just 20%, decision and recovery are 80%. And that's again, I'm reiterating myself, but that's also true for software engineering, right? You have been provided with codes, you have been provided with different multiple and all the fancy things in the world, but the real engineering is in decision making, what to use when, in what optimized format, and if it fails, what are the fallback strategies, what are your backup plannings and all of that stuff, right? So to make here in cases of LLMs a very strong MCP that ships to production, you have to do a coverage driven routing, right, where you cover as many diversified scenarios as you can. This really helps LLM understand the context, what are the decision making steps involved, how to approach them, and all of that stuff. Schema first execution, that every tool call is created with schema, no matter how small a tool call that we are trying to do, or perhaps even different API endpoints, everything should be coupled with a very hard coded that structured output, or perhaps schema, hardened schema. This might take a extra day or two efforts into process design, but that is definitely worth it when you're talking something to ship to production, because deterministic layers are very important when we talk about productions, right? Stochastic does not ship to productions. Then again, with every tool calls, since this is again open-ended streams, so it becomes really important to maintain that kind of your latency gates, timeout gates, throttling gates, concurrency limits gates, on all of the standard production software engineering gates, that what are your the number of tokens should not exceed this. So maintain a list of the standard gates, right? Your number of retries gates should be not more than 3 and all of that stuff. If it's happening, give a standard fallback route to that, and every maker should be coupled with a strong structured checker, that based on the structured schema, it should be the checker processes. When the tool call fails, triage, fix, fallback. There are 3 reasons that we saw that what a tool whenever tool in MCP fails, what are the 3 reasons. One, maybe the MCP have extracted wrong parameters. Your LLMs might have extracted wrong parameters. That's a very possible scenario. Wrong tool might have extracted right parameters, but might have called wrong tool at the wrong time. Actually, APIs are failing. The downstreams are actually facing. There might be throttling. There might be concurrency limited. There might be context, or there might be actual something that is related to that. So in all of these scenarios, there needs to be a fallback strategy. For example, if it has actually called a wrong parameter, it needs to understand, it needs to ask first of these, that what I'm doing out of all of these 3. If I have called a wrong parameter, what is the wrong parameter that I have called? Do the checking. How confident am I actually extracted the right parameter? The confidence still stays as the same. Okay, no, I have extracted wrong parameters, and still it is giving error. Move to the step number 2. What is the step number 2? Have I done the wrong tool call? Completely scenario. Are there any other tools that I could have called here that fits this parameter range based on the current parameter, or based off these? If yes, reroute to that. If not, the route is correct. This is the second tool. The third is, if all of these things are still fine and I'm very confident, and this is from the LLM perspective, that LLM confidence score is not moving, it is still very confident, move to the third. Is the underlying API actually failing, or there are throttling? So for here, I would suggest 2 things, right? There could be such multiple errors. So let all your API endpoints, let's assume that you're calling, in our case, when we were trying to build this for multiple 30 different MCPs, servers attached to one cassette, right? What we were trying to do is we had a wrapper over each API endpoint, and this wrapper had a very standard driven error messages. Whenever it used to throttle, it used to that I'm throttling. Whenever it used to say that there is a timeout, I'm timing out and all of that stuff. So it used to give you a very structured error messages also, and it becomes very important for your audit. It also becomes very important when your MCP is trying to understand that. No, this is a small snippet of kind of a healthcare application that we built here for one of our major client. So what exactly went here? So here the range of the MCPs that, or the perhaps tools that we integrated, were more than 45, 46. What we did here is we divided them into clusters, right? Whenever you talk about managing any kind of tool callings and all of these things, it's always better to do a cluster-based package management. There are a variety of reasons why it helps, but one of the shortest answer to that, it makes it easier to manage, it makes it easier to navigate. So we clustered it into EHR, FHR, which are all your EHR systems, anything that is related to EHR, healthcare, clinical side of data, scheduling, claims billing, knowledge search, analytics. These are the areas we divided our MCP servers into, which all of these are coupled with a lot of these tool callings. What are the different gateways? So whenever there, what are the client apps? The client apps are clinical portal, patient mobile apps, ops console, partner integrations. Anywhere it can start integrating, anywhere one can start consuming it based on the consumption pattern. That is also one of the parameters that kind of when you're designing from where they are consuming and all of that stuff is also very important. Hence, managing that data, logs, audit trail, session management into a dedicated database for MCPs is very important. That every tool call, every hit, every parameter that is extracted, the JSON, the tool calls parameters, the response payload JSON, the response JSON, everything should be maintained into a. It helps you, improve your system better where it is failing, doing that analysis as well. What is your gateway and orchestrator layer looks like? So if you look over here, there is an intent router agent. So this this is a planner agent also. This kind of identifies, okay, what are the multiple tool calls or 4 to 5 different tool calls or whatever it is, what I have to do to reach at this particular stage. Tool planner agent, it then selects what are the tools and workflows that I need to do. Based on this, okay, what are the parameter that I would need to extract from the user query, and what are the parameters that I would get further from different, kind of step-by-step chain process, right? So it would say, okay, in parameter, these are the parameters that I already have. Let's proceed. Based on that, what are the policy and permissions that I require for it? If I already have that policy and permission, if not, how to raise that? How do I get an authentication and all of that stuff, right? What are tokens I need to call off that? So this maintains that. What is a reliability and what is a verification agent? So this I'm now the agent has started orchestrating and the agent start kind of interacting. Okay, part one of the problem, I'll get the data from here. The reliability, the verification agent has verified it. The verification loops has passed. It started extracting the data. Move to step two, passed, extracting the data. Policy permission, authentication fetched, extract data, do this action, got this stuff, and it starts updating the user based on that, right? Whatever is happening, and hence the real-time audit logging, and you can show to the user what is actually happening behind the doors. Now, what is important is to how to keep the lights or how to keep this, kind of working in production. That is, whenever API upgrades happen, there needs to be version control. All these API callings, you should be very mindful that whenever schema changes happens, it should get upgraded, and the LLM systems should also start upgrading. Your MCP systems should also be very carefully managed about that. Everything should be backtracking compatible, all sort of this basic thing. Safer caching, previous call cache, TTL for reads, independent key for writes. This is also very important when you talk about production. When you talk about scale, the caching also becomes a very important layer because you don't need to do multiple calls. Underlying API calling limit is also very important to understand that, okay, underlying API calling limit can only handle concurrence of 20 and you're passing the request of 40. That is, your system is breaking somewhere. So all of these things also should be considered while you're doing that. Your tool budgets, your context layer, all of these are also very important when you're thinking about your MCPs in production. On a quick thing, this is how a production architecture looks like. Your intent of the region, the tool registry, auth broker, schema registry, caching layer, rate limit, circuit breaker, observability and logs, MCP, different kind of MCP servers, different functions, and based on all the different function calls, all the different tool calls, it is taking an audit log, it is registering, but it is a closed loop. MCP is always a closed loop. It is giving back to the runtime agent. Runtime agent is again giving back to the enterprise systems. So all of these is happening parallelly. This is what a production level MCP looks like.